That's enough of that. Need some water. Hey there.
Hi, how are you?
I'm good. I'm good. What can I do for you?
I completed, I'm in your pre-calc class, section 1, and I completed all the homework and everything, and I just have the quiz left, and there's 3 questions that are somewhat tricking me.
Okay.
So I have question number 3, which is for what value of x is the expression square root of 7x minus x squared defined as a real number?
Mm-hmm.
And it says enter your answer using an interval notation. I put 0, 7. Actually, I used all 4 tries out of 5, so that's why I didn't want to waste my last try.
I understand.
I put 0, 7, but if you have any tips on how to maybe redo it.
Sure. So you have an expression there looking something like the square root of some number squared minus x squared, right? Like,
It's some number. It's 7x minus x squared.
oh, okay. So let me change the 7 to a 5. 5x minus x squared. And they're asking for what values of x is this a real number, right?
Yes.
That's kind of equivalent to asking what is the domain, right?
Mm-hmm.
So what we need to do here is make sure that the object under the radical is greater than or equal to 0. Does that make sense?
Yes, I was going to say when you have to get the domain, I know we have to put it equal to 0, but every time we want to get the domain is equal, greater or equal to 0.
It depends on the situation. So we've got kind of those 2 different kinds of domain red flags. If we have variables in the denominator, then we need to make sure that the bottom, that denominator, is non-zero. And the way we do that is by setting the bottom equal to 0 and then kicking those out.
Okay.
But if you have variables under an even root, which is what we're looking at here, then you need to set the inside greater than or equal to 0. So here we're running into a problem of the second kind, where I've got variables underneath an even radical. And so the necessary condition to ensure that this doesn't output non-real numbers is that the inside is greater than or equal to 0. So in that case, in this case, we need to solve this inequality. And then the only thing I would advise here, because this is a nonlinear inequality, all right, the x squared makes this nonlinear.
Mhm.
We can't solve it by like trying to isolate x. Instead, what we want to do is factor.
Sure.
And then do that number line thing that we talked about back in section 1.8. The book presents it slightly differently. Sorry, I need to floss, so I'm going to turn my camera off. The book presents
No worries.
it differently, where they make a little sign chart. But I think the way we did this was by making a number line and testing some points. And they're really equivalent. Either way you want to handle it from there is okay. But the critical step here is realizing that you need to solve this inequality, and then recognizing that the inequality is non-linear because of the square. So we have to handle it kind of carefully.
Okay. So in this case, since it's 7, it's basically the same step, but I got x, parenthesis 7 minus x. So in this case, you will do x is greater or equal to 7. So you switch, or x is not equal to 7.
So let me run through it from here with the numbers that I have. So sort of my next step here would be to take the numbers that make each of these factors 0 and plot them on a number line. So this factor is equal to 0 when x is equal to 0. This factor is equal to 0 when x is equal to 5. So I would plot 0 and 5 on my number line. And then I would test a point from each of the 3 regions that creates. And check to see in each of those regions, is this inequality true or not true?
To see which one is positive. In this case, when it's positive, that'll be true.
Exactly, yep.
Okay.
So over here, we could test like -1. And here we could test any number between 0 and 5. I'm a fan of +1. And then over here, we could test any number greater than 5. I think 6 is a reasonable choice.
Mm-hmm.
If I plug -1 into this expression, I have -1 times 5 minus -1, which is -1 times 6, which is negative. So we get -6 is greater than or equal to 0. That's a false statement. So I would rule that guy out. And then between 0 and 1, between 0 and 5, we could test 1. So here I would have 1 times 5 minus 1 is greater than or equal to 0. That's 1 times 4. So 4 is greater than or equal to 0. That's a true statement.
True statement.
Yep. And then to the right of 5, what do we have? I could test 6. That's like 6 times 5 minus 6 is greater than or equal to 0, which is 6 times -1 is greater than or equal to 0, and -6 is greater than or equal to 0. That's not true.
That's not true either.
So for this particular guy, I would be getting the closed interval from 0 to 5. And we would have to check that the endpoints don't cause any trouble. Like you would want to plug 0 in here and verify that it's still a true statement, plug 5 in and verify that it's still a true statement. So what I'm getting for this one is the closed interval from 0 to 5. Yours might be a little bit different, but it should go very similarly. So set up the inequality, then pull everything to one side, factor, and then make your number line. The things that go on the number line or whatever make each of those factors equal to 0, and then just a point from each region, and that should do the job.
Okay, thank you.
Yeah,
and then if you have more time, can I show you the 2 others I have to?
sure.
Then I have 4. So what was the problem with 4? For 4, I have solved the nonlinear inequality and expressed the solution using interval notation, and then I have to graph the solution set. The nonlinear inequality is x minus 3 over 2x plus 1, and then it's smaller than 4.
All right. So let me, again, I'll just change it around again. How about like x minus 6 over 3x plus 2? And you said the right-hand side was 0, right?
The right-hand side is 4. It's smaller than 4.
Oh, okay. That's going to make things a little bit more challenging. Here, I'll put a 3 here. The idea here is the same basic principle, because again, it's a nonlinear inequality. The steps for these. First, we pull everything to one side. Then we combine into a single fraction if necessary, which will be necessary here. Then we factor everything, factor top and bottom. And then from there, we make our number line. And test points. So this is the sort of general strategy for solving nonlinear inequalities. Since we have a 3 over here, my first step, pull everything to one side. I'm going to subtract the 3 over. So in my case here, I'd have x minus 6 over 3x plus 2 minus 3 is now less than 0.
Mm-hmm.
And then in order to put these together, I need a common denominator.
So 3x plus 2 in this case.
Yep. Since I'm just picking these numbers at random, they might not come out quite as nice as in your problem. But now that we have that common denominator, I can combine those two fractions and I'll have x minus 6 minus 3 parentheses 3x plus 2. And all of that is over 3x plus 2. And all of that is less than 0. Then I would distribute this negative 3 over these parentheses and get x minus 6 minus 9x minus 6 all over 3x plus 2 is less than 0. And then finally, combining like terms, x minus 9x is going to be minus 8x, and minus 6 will be minus 12. And all of that is over 3x plus 2, and all of that is less than 0. Upstairs and downstairs here are both linear. There isn't really any factoring to do. But let's pause here for a minute. Are you comfy how we get up to here?
Yes, yes.
Okay.
I actually did the same steps. So as of right now, I'm pretty comfortable with this part.
Good. Okay. So because the top and bottom are both linear, there really isn't anything to factor. But what we do need to do is set each of these equal to 0. So the top will be equal to 0 when negative 8x minus 12 is 0, which means negative 8x is equal to 12, which means x is negative 12 over 8. There's a common factor of 4 there, right? So if I divide top and bottom by 4, I'll get negative 3 over 2.
Mm-hmm.
And when the bottom is equal to 0, I will find 3x plus 2 is 0, which means x would be negative 2/3. So on my number line, those are the guys I would use to divide up into regions. Negative 3/2 is like negative 1.5, and negative 2/3 is like negative 0.6 repeating. So negative 3/2 is to the left of negative 2/3.
To the right.
But now we're in that same sort of situation where I've got a number line and I'll just test a point from each region. And then at the end, we'll try to figure out whether we can include either endpoint in our solution.
Okay. And just to make sure, when I have to graph it, so of course I'm going to get the number that's positive. So I'm going to test all three different numbers, get the positives one. When you do normal parenthesis is when you do the negative or positive infinity, and then you do the little, how do you call that again? Sorry, like
the bracket?
The bracket parenthesis is when you do either the inside or two specific numbers.
Yeah, so like the interval bracket 0 to 3 parentheses, this is like everything from 0 up to, but not including 3. So it would be like all of this stuff.
Mm-hmm.
So the bracket means we're including that number in the set, and the parentheses means we're not including the number in the set. Is that what you were asking? I may have understood the question. Okay, cool.
Okay, no, that's what I meant. Because for example, on this one, we have a less than sign. I know when it's less than, that's when you use the normal parenthesis. So in this case, does that mean we will use just a simple parenthesis for both intervals?
Correct. Yeah, that's correct. So whatever solution we were to get out for this particular guy, because he's a strictly less than, I'm not even in a situation where I need to worry about including the endpoints, because these endpoints are necessarily places where this function is either 0 or undefined. And the places where the function is 0 might be interesting to us if this was a less than or equal to.
Okay.
But since it's a strictly less than, I'm not interested in places where this is equal to 0. And I'm certainly not interested in places where it's undefined. The one thing I would caution there is that in this case, and I think in yours also, because you said yours was a less than inequality, we're looking for places where this function is negative, not positive this time. If this was greater than 0, then I'd be looking for where this is positive. But because this is less than 0, I'm looking for places.
Oh, so we're looking, yes, that was a complete mistake. You're right. So if it's less than, you can look for negative.
Yeah, so I think of it like, I'm going to check if this is a true statement or not.
If it's actually less than
statement, then I include. If it's not, then I don't.
Okay, awesome. And then I have one last one,
sure,
which is oh, I have it here. So for the average rate of change of number 5, I have a square root of x over x plus 1, and I have to do the rate of change, average rate of change between 10 and 6. And the final number that I got down to is square root of 10 over 11 minus square root of 6 over 7. And all of this is over 4.
Sounds good.
I was wondering, I'm going to try to input it like that. I actually did not, but I was wondering if I had to simplify it more, and if I do, how?
Let's take a look.
I'm going to try to simplify it to put it like that, see how it comes out.
So yeah, since you've already done the basic computation there, I'll go ahead and just write down what you have, and then we'll look and see if there's any natural way to simplify. I do think there is some work that can be done, but only so much, and it should accept it as being correct as long as it is correct, regardless of whether it's simplified. So this would be f of 10 minus f of 6 over 10 minus 6, which is 4. And that is root 10 over 11 minus root 6.
It accepted it.
Okay, good. Now, if we did want to clean this up, and we could, the steps would be like this. We would want to have a common denominator between these two terms up here. And that denominator would be 77. So this would be 7 square roots of 10 over 77 minus 11 square roots of 6 over 77, all divided by 4. And then there's not much we can do upstairs with the square roots besides write them as a single fraction like this, and then say that dividing by 4 is the same as multiplying by 1/4. And I'm going to need a second to do the arithmetic here. 7 times 4 is 28. So this is 280 plus 28, which should be 308. So this would be 7 square roots of 10 minus 11 square roots of 6 divided by something like 308. But it's a matter of taste. Is this any nicer than this? I don't know. And certainly this is correct. I would accept this. If all I asked for was the average rate of change, this is fine.
Okay. And I'm sorry again, I did forget. I do have one last domain to find that I missed on 2 different
Sure.
pages.
No, we have plenty of time. Yeah. Let's take a quick look at that.
Is square root of x plus 1 over x.
All right. So let me get you started on this one. Since it's a quiz problem, I don't want to work it entirely for you. The domain red flags we see is that there's an x plus 1.
There's an x underneath.
Yeah, inside a square root. And there's an x downstairs. So we need to kind of make sure neither of these cause us trouble. This first guy is going to require that x plus 1 be greater than or equal to 0. And the second guy is going to require that x is different from 0. So you'll solve this inequality, and then in addition to that, impose this requirement. And I would recommend like drawing it out on the number line, shading the regions that satisfy both of those conditions, and then that will be your domain.
Okay. And when it comes to red flag, for example, the x plus 1 inside the square root, we always have to put it as bigger or equal than 0.
Correct. Yep. Yeah, because if we take a square root of something that's less than 0, we'll get out non-real complex numbers like I. So we want to avoid that in this class.
I'm just writing it down to do it.
Sure.
All right. Well, I'm gonna do them now, and thank you for your help. That clarified a lot of stuff.
Yeah, of course. I'm happy to do it, and I appreciate you taking the time to work through the quiz in the way that you're doing. I think it will serve you well. So
I hope so. I'm trying.
oh, very good. You're doing great. You're doing great.
Thank you, Professor. Have a good day. Have a good weekend.
Yeah, you as well. Sarah, what can I do for you?
Hi, mostly just checking in, like a progress report style. So I don't know if you saw in WebAssign, I completed the homework. That first homework assignment is all, I believe it's submitted. It doesn't show like an actual, your homework has been submitted when you
Let me
click the
take a
submit button.
look. Yeah, WebAssign does a pretty good job of automatically saving, but I'll take a quick look just to keep you from having to worry. So for the first homework set, yeah, I've got you at 128 out of 128. Perfect.
Okay, cool, perfect. Okay, so I did that, and I'm hoping to crack into the second homework set today, and then I still have to make up the end of last Friday's class because I lost internet at about, I think 11:35-ish. I lost internet, which won't be an issue anymore because now I'm free to leave my apartment. And then also, yes, it's very exciting. And then this past Wednesday's class as well. So I still have to go through that and then continue working through those homework assignments. So I'm hoping to be here today until 4. I'm hoping to be here Sunday as well from 12 to 6 when the Learning Commons is open.
Cool. Yeah, that sounds like a good idea.
So I'm just hoping to just kind of work through it as much as possible. So I'll just kind of keep you posted on my general progress.
Okay.
And then aside from that, oh, for student teaching, I reached out because I didn't really want to do the student teaching on my own if it was possible. David Dunn is doing 6-1, and he's looking for somebody to do, I think it's the area between curves.
Yeah,
So I was thinking I might partner with him for that.
okay. And the other person who still hasn't committed to something is William Malot or Malot. I'm not sure how to pronounce if it's French or not, but William also hasn't chosen a section. So if you wanted to work with him, that would be an option too. But if you've already spoken with David, I can put you down for 6.1 with him if you guys are on board for that.
Yeah, sounds good. I'll like doubly confirm it with him. But I reached out on Canvas just to everybody, to see who had something they wanted to partner with, and he said
Okay.
that he's down. And it's
Alrighty
definitely
then.
out of the scope of September, so that's all good.
Yeah, okay. That works for me then. I'll go ahead and add that to the spreadsheet and you are all good on those things. I got your honors project as the Archimedes principal and student teaching, you'll do 6-1 with David.
Okay, sounds good. I'm hoping to crack into the Archimedes principle after I'm done catching up, so it might be a little bit, but I'm hoping to check the Wikipedia page that you recommended. Sounds like a really good
Okay.
idea.
Yeah, it won't be a huge time sink, just when you do get a few minutes to read and cook up a basic outline, that would be a sufficient first step.
Sounds good. Sounds good. Okay, but yeah, that was basically it. And then I'm gonna dive into 2.4 and 5. I'm hoping to cover through those today.
Okay, that sounds good, Sarah.
Perfect. Thank you so much for your help with all this. I really appreciate it.
Of course, yeah, anytime.
Sounds good. And next absence will be this coming Wednesday. That's the next holiday.
Okay, yeah, that shouldn't be a problem. Just take a look at the video. I'll try to get it posted nice and quickly for you after class.
Sounds good. Appreciate it. You have a good one.
Of course, you too.
Yeah.
That reminds me, I need to upload today's stuff. How you doing, baby man? No.
He took a little nap earlier, and I know he's tired because all he's doing is fussing. Or was fussing.
Yeah, he seems a little fussy. Has he eaten recently?
Yeah, I mean, he ate that bottle and Maxie's out with the light.
Yeah, he's probably all fucked up.
Maxie? Are you breathing?
Yeah, thankfully Benadryl in an overdose won't stop you breathing. Actually, you go quite crazy. You get a fever and stuff. But I don't think he's, I don't think he's experiencing any sort of anticholinergic poisoning. I think he's probably just loopy and tired. Good boy. We do love you, Moose Wallace.
You can go on a run. Look at the Maxie.
Yeah, if Johnny needs something, I can just remaining meetings. Office hour for another 30 minutes, calculus meeting at 2, and then mentoring meeting at 3.
Do you think we're good?
Yeah, all the remaining shit is pretty loose. I can always
Maxie, you feeling loopy or going?
he's probably still pretty tired. Oh, let's see. Yes. Yeah, I mean, you can take vitamins if you want. What? We can get some. Hey, Angeline, you there?
Yeah,
What can I do for you?
so I have a question on the homework. I have a few of them.
Alrighty, let's start with whichever one shows up earliest in the homework set, because they kind of tend to build.
Okay, let me see where I'm at. So I needed help with the first one. Let's see. Four, 14.
Alrighty, and that's in homework 4 in Mac
Yes.
1140, is that right? All right,
Yes.
I am just posting a video right now. 10 seconds to get this link up, and I will pop open that homework set. Publish, not for kids. Over here to OH1. And edit this announcement. All right, here we go. So homework 4. What question number was it?
14.
14. All right. So that's where you have some number over x, right? G of x is like 7 over x or 5 over x. And you want to find the net change and average rate of change from x equals 1 to x equals a. Does that sound right?
Mm-hmm.
All right, let me turn on my screen share here. This is the particular guy. The red here indicates that this is a randomly generated thing, so your numbers may be a bit different. But I can show you how to do this one. We can kind of work through it together. Does that sound good?
Yeah.
All right. So f of x is 7 over x, and we want to find the net change and average rate of change, both from x equals 1 to x equals a. So in part A, the net change, do you remember what the definition of net change is? What do we need to begin with?
What did you say? I'm sorry.
Do you remember the definition of net change? Where do we begin if we want to do a computation like this?
Well, wouldn't you do f of a minus f of 1?
Almost. It's actually a little bit weird here. In this particular problem, because I said from 1 to a, the normal a's and b's in our theorem or definition are the smaller guy a is 1 and the larger guy is b. So here it's true that we're always going to compute like f of b minus f of a over b minus a. Here the letter a is being used twice in a way that's kind of annoying. But really the b in this formula is the number a and the a in this formula is the number 1.
Yeah.
That could be the issue. So this would be f of a minus f of 1 over a minus 1. So kind of when you say from here to here, they're implying that this is the larger guy, the thing that we call b in the formula.
Yeah, I understand how to get the net change. I just didn't know how to find the average.
Oh, and here what I've done foolishly is written down the average rate of change. Sorry. Yeah, so this is the formula for the average rate of change. I'm thinking ahead. The net change is just f of b minus f of a.
Yeah.
All right. So then let's run through this. This is the one that we need, right? The average rate of change. This is part B. So that would be f of a is 7 over a. F of 1 is 7 over 1, right? Because f of x, f of anything is 7 over that thing. And then downstairs, we just have the a minus 1. And remember, the big fraction bar implies parentheses like this. So if I just wanted the net change, that would be this numerator. And then the average rate of change is this whole thing. Simplify this quite a bit. So let's see how much we can simplify this. My first step would be to have a common denominator up here. So what would I use for the common denominator here?
I would use a, like 1a.
Yep, exactly. A, or a times 1. So this guy's already got that denominator. This guy needs to be multiplied by a over a. So this would be 7 over a minus 7a over a, all divided by a minus 1. And then I can subtract those two fractions as 7 minus 7a over a. And a minus 1 is still downstairs. And now this last step, I would say, okay, the top of the big fraction is this thing in parentheses, and it's all being divided by a minus 1. So this is 7 minus 7a all over a times the reciprocal of a minus 1, which is 1 over a minus 1. And how much you want to simplify from here is kind of up to you. The numerator, I can factor out a 7, and I get 7 times 1 minus a. And the denominator, when I multiply these, I get a times a minus 1. And the 1 minus a and the a minus 1 have an interesting relationship. It is possible to clean it up further from here, but let's pause here for a minute. Are we comfy up to this line?
I'm sorry?
Any questions so far? Are you comfortable?
Oh, no.
Feeling good?
Yeah.
All right. So here's a neat fact. X minus y, if we multiply that by -1, or just slap a negative out there, that would be the same as negative x plus y when we distribute. And that's the same as y minus x. So in other words, if you have a difference of two terms like y minus x, that's the same as the negative of that same difference in the other direction. What this means is that 1 minus a is the same as negative times a minus 1. And I can use that here. So this yields 7 times 1 minus a over a times a minus 1 is the same as 7 times negative a minus 1 over a times a minus 1, which is negative 7 times, because this is multiplication, times a minus 1 over a times a minus 1. And then we can cancel the a minus 1s, and we actually just get negative 7 over a, which is pretty slick. But if you wanted to stop here, that would be okay too.
Okay. Okay.
All right.
What time is it? 'Cause I don't want to. I totally lost track of time, so I came really late.
Oh, no, it's all right.
Could you do 15?
Yeah.
I was watching the video, and I didn't quite understand why they did what they did. So I guess you could continue to.
Maybe I'll ask you to sort of walk me through what you think are good steps for this. And this time, let's do the net change first, and we'll try to simplify that.
The net change.
Yeah, because in
What I
15, they want both the net change and the average rate of change again, right?
Yeah. I can't see your screen has.
Oh,
So-
weird. Okay, let me turn the screen share back off and then back on. Sometimes it does that. There you go. Is that better?
Oh, I can see your screen, but there's something in the corner. It's from WebAssign.
Yeah. So this is the statement of the problem that we want to work, right? So,
Yeah.
yep, I've got it up here for myself so I can see it. So it says
Oh,
net change from 0 to h, and then find the average rate of change from 0 to h. So I'm just writing it down. Here's our function. And we want to work from x equals 0 to x equals h. And we want the net change. And we'll just jump in and do that first.
so what I would do, or what I did, is I plugged in the numbers, but I did. So I had 6 h plus 3, well, over it. So 6, and then instead of x, I put h.
Good. Yeah. So we need to start with g of h minus g of 0. And your g of h is good. That's going to be 6 over h plus 3.
And then I subtracted that, and then I just plugged in 0 for the other side.
Good. All right. So we're looking at this. And then 0 plus 3 is just 3. So I could write this as 6 over h plus 3 minus 6 over 3. Then 6/3 is 2. So this is 6 over h plus 3 minus 2.
So the one that I did, because the one that they did, it also simplified to where I didn't have a fraction. But the one that I have has a fraction. And so that's where I'm more confused, is what do I do with the fraction?
Well, let's pretend we were kind of stuck here, right? Maybe we change the 6 to a 7 or something. So this would be 7/3.
Yeah.
You can still say this is the net change. Let me go ahead and do that. Let me change this 6 to a 7 everywhere. Okay, so we'll say forget this line, right?
Mhm.
The next step would be to have a common denominator.
Okay.
So this guy has a factor of h plus 3 downstairs, and this guy
Mhm.
has a factor of 3 downstairs. So my common denominator is going to be h plus 3 times 3. So the 7 over h plus 3 would get multiplied by 3 over 3. And the 7 over 3 would get multiplied by h plus 3 over h plus 3.
Okay.
And then when we multiply these fractions, remember the tops and bottoms are always in parentheses. The top here, 7 times 3 would be 21. So I'd have 21 over h plus 3 times 3 minus 7 times parentheses h plus 3 over 3 times parentheses h plus 3. And now that those denominators are the same, we can subtract the tops. So this is 21 minus 7 times parentheses h plus 3 all over 3 times h plus 3. You can write the multiplication in either order. Then I would distribute this 7. So that's 21 minus 7h minus 7 times 3 is 21 again, all over 3 times h plus 3.
Mhm.
And the positive 21 and negative 21, they'll eat each other up. And we'd be left with something like negative 7h over 3 times h plus 3. That would be our fully simplified net change.
So why wouldn't you, what's the rule on why you can't cross out the H's? Like, is it because you have to be able to factor the H out on the top for you to cross them out?
That's correct. So the top here does have a factor of h, right? Like negative 7 times h. H is a factor of that expression, but h is not a factor of the bottom, right? I can pull an h out from this.
Okay, I see.
Right, because the 3 right here, this guy doesn't have an h that I could factor out.
Okay,
We could factor out an h, then we would do that. The neat thing though is that the average rate of change would be the same thing, g of h minus g of 0 all over h. And we just computed g of h minus g of 0. That's negative 7h over 3 times h plus 3. So when I divide that whole thing by h, this is going to give me a factor of h in the downstairs that I can cancel. I leave the top alone, negative 7h over 3 times h plus 3. And I multiply by the reciprocal of the bottom. And then multiplying those fractions, we get negative 7h over 3 times h plus 3 times h. Now I do have a factor of h downstairs, and I can cancel this one with this one.
okay,
Your part B, your average rate of change, will have a piece you can cancel, and you get negative 7 over 3 times h plus 3 without the h upstairs.
okay. Okay, that helps. And I have one last question. And that was 17. And that was the last one.
All right, this is similar. Let me see, do we have, is this all of those? I would like to make sure I'm leaving one of these for you to work out. This one does require a little bit of a trick though. So let's set this up and then I'll let you work on the algebra yourself because I don't want to deprive you of that experience. So f of t, they call it, is 4 times the square root of t, and we want net change, net and average change from t equals a to t equals a plus h. So I should warn you first, some variation on this question will show up on the test. So it's something that you want to make sure you practice until you're comfy with.
Okay.
Let's look at the net change. That would be f of a plus h minus f of a. Right, because like this is my b, this is my a. And that would be 4 times the square root of a plus h minus 4 times the square root of a, right? Because if I plug in a plus h for t here, I get this. Plug in a for t here, I get that. And you could in theory just say, I'm going to stop here. That's my net change. I'm happy with that. But when we look at the average rate of change, we know our goal is to cancel the h from the bottom. So my next step here, you can either do it on this part or you can do it later when you get to the average rate of change part, would be to do something called multiplying by the conjugate. So what I'm going to do is I'm going to take this and I'm going to multiply it by a certain fraction, which is going to be what I get by taking this expression and changing this minus to a plus. So this will be 4 square roots of a plus h plus 4 square roots of a. And if I'm going to multiply by that upstairs, I got to multiply by that downstairs. So this is a sneaky algebra trick called multiplying by the conjugate. And it's nice because something really fantastic in the numerator happens when you FOIL all this out. Again, you don't necessarily have to do it for the net change part, but you would need to do it for the average rate of change part. So let's just get it done now. My firsts are 4 root a plus h times 4 root a plus h, which is 16 times root a plus h squared. That's my firsts. My outers are 4 root a plus h times 4 root a, which is 16 root a plus h times root a. My inners are the same thing, but with a minus. That's minus 16 root a plus h root a. And my lasts are minus 4 root a times 4 root a. That's minus 16 root a all squared. And then downstairs is just this piece, 4 root a plus h plus 4 root a.
So why wouldn't you? Oh, never mind. Wait, no, why would you put the plus down there?
Why would I do what?
Well, if you're taking, you know how we're trying to find the average of change and you would do b minus a, would you just change it all together?
So right now I'm just working on the net change.
Oh,
So we're gonna simplify this net change as much as we can, and that will make the average rate of change stuff easier. But these algebra steps that we're doing here, you could do them with the average rate of change step. I'm just doing it here because I know I'm gonna have to do it later. But the reason we do this, look at these middle terms. Plus 16 root a plus h times root a minus 16 root a plus h times root a. This and this eat each other up. And then the square root of a plus h all squared is just a plus h. So this is 16 times a plus h minus, same sort of thing here, 16, and then the square root of a all squared is just a. And then downstairs, we still have that expression of 4 root a plus h plus 4 root a. And the nice thing here is that when you distribute the 16, the 16 a's go downstairs. You could factor a 4 there. And we get this, the 16 a's eat each other up. And now, just like the previous problem where we had a factor of h upstairs that we were unable to cancel in the average rate of, or in the net change, when we write down the average rate of change, we'll see that we can cancel that h upstairs. So this is kind of as nice as we could possibly write this net change. This is kind of doing all the work here that we would normally do in the average rate of change part of the problem. But just kind of looking forwards, knowing that we're going to want to cancel the h from the bottom in the average rate of change. If we work the net change until the top has a factor of h, that will be easy. So now the average rate of change would be f of a plus h minus f of a all over a plus h minus a, which is f of a plus h minus f of A all over H, which is this thing we just found. 16H over 4 square root A plus H plus square root A, all divided by H. And we can cancel the H. So if we write it like this, we can see that the H down here cancels with the H up here. So our average rate of change looks like we can also interact with 16 and the 4 is going to be 4 over square root A plus H plus square root A. But if you want to save that multiply by the conjugate algebra stuff for the average rate of change, you can. It's up to you, but you got to do it somewhere.
Okay. That makes sense. I watched the video and I was like, I don't know what they're doing because, they skip steps in the video. So I was like, I don't know where they did all this from. But
It kills me that when I look at this assignment as the professor, it doesn't give me the option to watch the video. I'd love to see what it is they're doing. Maybe I'll switch over to the student view and take a look.
they did the same exact thing you did, but I just didn't understand why they were doing it. So it's like nice to hear why.
Oh, I see. Okay. Cool. You feeling comfy with this now? Is this making sense?
Yeah, it is. It is.
right.
Is there a way I can get this recording?
Let me see. Yeah, we are recording this, right?
Yeah.
So, which section are you in? What time does your class meet?
Mondays at 8. Monday and Wednesday at 8 a.m.
All right, so that's OR1. I can, maybe it would be easier if I just sent it to you directly. I don't want to confuse people by posting the office hour. But here's what I will do when I finish. So after I close the Zoom meeting, it'll convert into an MP4. I'll upload that to YouTube and just email it to you directly. What is your email?
My SF one.
Whichever one you'd prefer to receive this at.
I'll do the SF one. It's my first name dot my last name. So ANGELINE and then dot JEANTY at sfcollege.edu.
Is there a go.sf or just SF College?
That one right there with my picture.
All right. Oh, damn. Sorry. There it is. All righty. Office. Recording. Okay, I was working with some other students in here a little bit earlier, so you'll see that. But just skip ahead and you'll find
Okay.
the option here.
Thank you.
You're welcome. Take care.
You too.
And we're at 2:03, so I'm going to end this.